Hello, everyone, and thank you for coming to this user meetup. This one is a special one because we're going to talk about Ladybug Tools integration with Pollination and discuss how, as current Ladybug Tools users, you can take advantage of Pollination to take your workflows to a new level from several aspects. So we did the polls already. This is what we're going to go through, right? I'll give an update from the product, then we start the demo. Chris will start the demo, I'll help. And then we have a Q&A at the end. We usually have like a short Q&A before the demo too, if anyone has any questions. So what's Pollination? Is an ecosystem of tools for environmental building design and simulation. Our goal is to get you from question to actionable data quickly. And we do that by helping you during the modeling, validation, simulating, help you scaling, visualizing the results, customizing your solutions, and create new ones, and collaborate all together. So the ecosystem has different pieces. There's cloud involved. We have the web interface, plugins, and then apps in the middle that brings everything together. On the plugin side, we have the Rhino plugin, which we will show today. A lot of it. We have the Revit plugin that will help you easily export a BEM model, building energy modeling, or building performance modeling model from your building information model. We have the Grasshopper plugin, which works closely with the Ladybug Tools Grasshopper plugins. From all these CAD plugins, you can actually export to all these formats. The formats that we have there, we directly export to them. So you can either use GBXML to go to this tree. You can use GEM to go to IES, HVJSON that we will use to use with Honeybee, IDF, INP, OSM, RAD, and BTK. These are all the different formats that we support currently and more to come. Then all these plugins are connected to our cloud computing services using the API. And on the cloud side, we have cloud computing. We have repository for apps and recipes, so you never have to start from scratch. And then we have a web interface that adds features like projects and galleries on top for you to be able to collaborate. We will show some of that today too. Then apps are the newest product that we're working on, and it's alpha. We will release it soon. You'll see some of it. We have shown it before during the user meetups. But what they do, they're web applications that you can load from the CAD plugins. They take advantage of our cloud computing resources, and then you can also use third-party APIs to build your own apps. And last but not least, because the API that we use internally is also available to you, any third-party app can build their platform on top of Pollination and use all the goods in Pollination to save a lot of time to start their platform. What are the product updates? Rhino plugin, we improved the validate workflow, and we'll show it today. So now you can, instead of getting only the error messages, you can click, and it shows you where the validation error happens. We also added a web page that says what every validation error is. Again, we'll show it today. On platform, we have an improved header. We redesigned the platform. So if you go to app.pollination.club, probably you won't see the apps because they are behind a feature flag. They're hidden right now, but you'll see the header now, like you have easier access to all your profile apps, projects, and there is a drop down here to move between your personal account and organization overall, and you see there is a new color in the background. It has been improved. We have worked on apps. They haven't been released yet publicly, but so you know, they are coming. We have a new dashboard instead of what you have right now that you see project, you see series of apps. We have apps for Rhino, Revit, or apps that you can use from the web. We also have a prototype app that connects to SimScale for outdoor comfort. This is something that people ask about because we don't support Butterfly yet. On Pollination, this is a way for you to get your CFD simulations loaded into Pollination ecosystem and then use the rest of Pollination recipes and visualize the results. Something to be excited about. As you can see, we are moving all the apps that we developed to be production level apps and be accessible on Pollination. And apps are coming for Revit and SketchUp. So if this is your first time, as I said, these are web apps, but you can load them from CAD plugins, and then they work like CAD plugins. So an app will be a Revit plugin. This one is for daylight simulation, or it can be the same app, can be a SketchUp plugin. So the same app, you can open it, it links to your model, it loads the model, you can run the same simulation, and you can push the result back and visualize it. So that's what's going with apps. We are definitely really excited about apps and how it can save everyone a lot of time for writing apps first, using them, and maintaining them. And then on Grasshopper side, we added 2 small components for add a project and get a project. There was a request for this to be able to create projects from inside Grasshopper. So this is now added and make things easier. So this was the last one that they had. And with this, we're going to start the live demo unless someone has a question. And I stop presenting so Chris can share. Is there any questions? You can type it in comments section or chat. Okay.
All right, then. Everyone can hear me all right? Wonderful. Okay. All right, so thank you, Mustafa. As Mustafa said, we're going to be covering today a lot of workflows with the Pollination Rhino plugin, and specifically how your current workflows with Ladybug Tools can be enhanced by using the Rhino plugin. But I'm going to take the first kind of 5 minutes here to kind of review some of the kind of pain points that happen when using Ladybug Tools to build particularly large energy models. We're going to use a relatively small sample here. This is, a lot of you probably recognize the Revit sample model here, the 15-room model. But I'm going to kind of review some of the kind of pain points that happen in this, because while we all know that Grasshopper is a really powerful interface for data analysis and post-processing, it can be really painful sometimes to construct these large energy models and manipulate the geometry in this interface. So for example, this is a Grasshopper script that right now, if you were to try and build an energy model with this Revit sample, this is about what a Grasshopper script with Ladybug Tools would work like. That we usually have to bring in each set of room volumes that has a different program that's going to have a different sort of component that's creating those set of rooms. We have a bunch of adding in apertures and doors to this. We have to solve adjacency, adding HVAC systems, right? There's a kind of a lot of spaghetti in the setup of this model. And usually we also have to have some, visualization of the attributes to QA/QC things. But the thing is, right, while this script actually looks nice and neat and clean, if I were to actually go and run this simulation right now of this Revit sample model that I built that has just 15 rooms in this case, right? You'll see that I can actually translate the model over to an open studio with Ladybug Tools perfectly fine. And I'm waiting for my simulation to start, and oh no, something went wrong. And those of you who have used Ladybug Tools a lot have probably encountered something like this, right? So something went wrong in the simulation, and Energy Plus has given us this readout with a bunch of unique IDs here. And I can see, okay, there's something definitely wrong with the doors here. There's something wrong with these corridor rooms, and you can go and spend a good 20 minutes trying to figure out what's actually wrong with the model here. But because I made this model and I kind of know what was wrong with this, I'm actually going to fix it right now. So I know one of the problems that I had here is that I had some duplicated door geometries in the interior doors I had here, and this resulted in a bunch of wrong problems. So I'm just going to connect up these correct doors that I know that don't have those duplicated geometries here. And there was a problem also with the corridors. They weren't properly intersected with one another, right? Again, this would probably take me a good 20 minutes to debug this, using Rhino Grasshopper and having to run it each time to figure out if this is right. But now you guys can see let me unlock the solver here, right? If I go and run it now, at least I'm not going to wait for the whole simulation to finish, but you guys can see, trust me, okay, simulation can actually run this time. And I'll just wait till it warms up so you guys can actually understand this. But now the thing is, right, even if the simulation actually starts up and runs, right, everything is warming up, at least the simulation is going to be successful at the end of this. There are still some big problems actually with this model. And so to kind of go back and show that even when you actually have the simulation running successfully, if we go back here, you'll see, right, there's a component that turned orange. And there's some of the, one of these aperture geometries, one of the window geometries was not matched with any face. And, I get the idea of that face here, but, I have no idea where aperture 72D, so-and-so is in this model, right? I got a lot of windows in this model. It's going to take me some time to go through and figure out which one is exactly wrong here. The other thing is that, if I actually were to take a look at some of these QA/QC components here, and I turn the preview off on this color by face, which we're currently seeing in the scene here, and I just look at the indoor surface boundary conditions, you see that, some of the adjacencies have solved correctly so that I'll get matching heat flow, but there are definitely some cases here, right, where I know these are surfaces that should be interior, but they're not being set as interior here. And I would have run the simulation, I could have looked at the result, and that result would have been wrong, or it wouldn't have been really a good representation of what this building actually is. So, so there's a lot of QA/QC that you need to do right now in Grasshopper. Usually it takes a lot of iterations. You have to run the simulation each time and make sure that things make sense for you to finally arrive at something you can actually use to inform the design. But now that we've kind of reviewed some of these pain points that maybe a lot of you are already familiar with if you've built larger energy models within Grasshopper, now I'm going to pass this off to Mustafa, and he's going to show you how, with the Pollination Rhino plugin, a lot of these pain points become much, much easier to manage and much, much easier to address. So, all right, let me stop presenting right now so that Mustafa can take over. But we're going to use the same model, by the way, for this. It's got the same issues, the exact same geometry that we're starting from, and Mustafa is going to fix these errors.
Right. We thought to use Pollination, actually. You can upload and download the model from Pollination, but that might have been like a little bit out of the scope for now.
Yeah, and we're trying to be quick today.
This is the Rhino plugin. Right. This is the Rhino plugin. If you haven't noticed, when you install the Rhino plugin, there is a panel here for pollination. If I type PO underline, these are all the commands that comes with pollination Rhino plugin. An easy way to get it started usually is like if you click here, you can see some of the most important ones that we call repair commands that you can use for repairing your model. So we have good tutorial for all of this, so you can go and watch them. This is all the rooms here. Now I can select one by one. So what I'm going to do, I'm going to just jump on fixing the model. So Chris sends me this model and says, there are issues. Can you check this model? So the first thing I'm going to do is I'm going to run this command called PO check. So this is the first command that I usually run on the model. What it does, it helps me to find points that are very close, but they don't exactly touch. These are the ones that makes the model fail in two ways. Either makes very line-like geometry, or makes issues with solid adjacency. So now I have a few of them. I can click on them and see them right in the viewport, or I can just zoom in myself. So you can see this model has like a small tiny edge here that I had. Maybe I press F7, so yeah, you don't see the background. So now you can see this. So how do I fix this? The way I fix this is I can go and edit inside and join these two faces, or it's easier if I do PO rebuild rooms. And it rebuilds this room and it fixes that. So I still have one issue here. So let's look at this one. So this one, it looks like we have this room, you see, inside the other room. So this one, my bath, the way it's modeled, it's not modeled correctly, so it's coming a little bit here inside this, and that's causing an issue. So I can do move edge, and I'm moving this from here to here. So what happened is I fixed those two issues that we just talked about, and that interface updated live. Again, all this are simulatable zones, rooms, and I have access to all the faces and what's the program and everything. So now what I'm going to do next thing is I know they're not points that are that are closed but are not touching, but let me validate the model. So we have a command called PO validate model. What PO validate model does, it basically goes and checks for all the typical mistakes that we have seen people have been making during the last 9 years using Ladybug Tools, including ourselves. And we check for all of those. So let's check them here. So now I have 3 errors here. There is one invalid subface geometry. This should be an easy one to fix. So I can check here. There are some long things that either you have to go read, or you can click here and say show. And when you do show, it basically shows what's the error. This one is an easy one because it says found invalid subface. But if I didn't know what this means, there is a button here for more info. I can click on it. It takes me to this web page, and it gives me a detailed explanation of what this is, and then it says the best way to address this is to zoom and try to fix it. Okay, now I know the best way is to zoom and try to fix it. I already zoomed. Let me try to fix it. So the way to fix it is to move this edge up, right? And for me to do that, I try to do it, and it won't work because everything is a room. I won't have access to that edge of the window. I can select the whole room. So how do I make that work? There are 2 different ways. One is I'm going to here and turn off the room selection. When I turn off the room selection, now I can access this child objects directly. Do this, but if you know what are you doing, because what I can do now is I can move this window outside, or I can just move this room without moving the windows. So this is for more advanced users. The other way of doing this is to say, okay, let's not do this. And instead of doing that, you can double click on it, and then you will go into the edit mode. The edit mode means like everything else is now frozen, and now you have access to this. So this is a little bit more reliable. So what I can do move edge, and then I can move this. In here, I could have done scale 1D. I mean, this is Rhino, right? You can do whatever you want to do, and you're used to do it. So this is done. Let's revalidate model. Okay, I got that one was fixed, right? Now I have another one here for finding missing adjacencies. So it's telling me like there are two faces with missing adjacencies. So let's watch. So it's happening between these two. And then if I click this one and press show, oh, this is happening here. Why is it happening here? Is because, do you remember I rebuilt this? And when I rebuilt this, it removed all the boundary condition. How can I visualize this and make sure this is happening? So there is a feature here, color by boundary condition. And then now everything is blue, which means it's outdoor. And then what I can do, I can go here and filter by boundary condition. So I can say, don't show the outdoor ones, and refresh this. Now you see what's happening. If I isolate this, these faces that were supposed to be interior, they're not interior anymore because I rebuilt the room. It removed all that. So let me show everything else. So what would be the way to fix this? I can just do solve adjacency. If I didn't know, where is my PO validate command? If I didn't know what's the fix, again, I could have clicked here, more information, and then it says missing adjacency. The best way of doing it is by resolving adjacency. So what I can do here is I go here and I do PO resolve adjacency. Is that resolve? PO
Solve adjacency.
solve adjacency, sorry. Solve adjacency. So now I can select all the rooms. And this model, intentionally, we made it a little bit worse than what this usually will be. So you guys get a little bit of a sense. But in larger models, we have dealt with a lot of models with like similar issues that there are like so many issues. You do solve adjacency, you get new errors. And in Grasshopper, the problem is every single time you have to redo this, you have to rerun everything. You just know there was a problem. The good thing about Grasshopper is just you do it once, you fix it, you're done, it's fixed. So let me, now that I solve adjacency, do PO solve adjacency again and see if anything new will come up. Oops, no, sorry, PO validate again. So here we go, and now I have 15 new things, and there are missing multiple adjacencies. And this is the time that you usually give up on your model, but here you don't have to, because you can show here, and now you will see what happened. So we had this a small, what is this? Shaft, which is now, this shaft is actually extruded a slightly thing. I know like you're thinking like, that's not me. Yeah, I know. Like we all think that's not us. So, and like one more thing that has happened here, if I isolate it, because I did solve adjacency, now we have this small edge that's between the two. We didn't catch this because of the tolerance that for that PO check geometry adjacency one. If I had put more tolerance, I would have seen it. But it's a good time still to catch this. So what's the fix for this? The fix for this is to move those edges, right? So I can just do show. If I move this edge and this edge, this should be fixed. But before doing that, I want to remove that extra line that I created there. So the way to do it, by now you should know what's the command for that. So the command that I'm going to use is PO rebuild room. That's fixed. And then I'm going to do move edge and move this edge from here to where is it? To here. If you're not a Rhino user and I'm getting you confused with all those things, that's fine. When you get used to Rhino, these are easy things to do. Okay, so let me revalidate. That one is done, or is it still there? Oh, I have to resolve adjacency again after fixing it, right? So what I'm going to do, I'm going to PO rebuild the whole model because I want to remove all those small edges that I might have built last time that I did it. And now you can see, because I had that filtering, like everything is outdoor, I don't see any indoor. These ones are touching ground. And now if I go ahead and do another round of PO solve adjacency on my clean model, and wait a little bit. So let's see. Most of the things should be resolved. This one is still an issue. Let me do PO validate model. And now I have to get like some other errors, like this air boundary thing. And this is, again, intentionally we put it in. So you see like how this thing can get really frustrating. So the thing that's happening is here, this hull face. So if I show this face, this between the two, this is an air boundary face. So the way I can show it to you is if I select this room and I can go here, you can see these faces are air boundaries here, right? And this one, when we rebuilt this, it made the whole thing air boundary because this one with the larger area was air boundary. So this should really be a wall. So I can double click here and change it from air boundary to a wall. And that should resolve one of the problems that I have here. Let me revalidate so you see this is one. And I can go ahead and just fix all this stuff. But because of the time we're 11:28, I think I'll just stop here. Anyone has any questions so far before I hand it over to Chris? Okay, what's
There's
that?
no questions in the chat, but if anyone has live questions, you can feel free to unmute.
Okay, while waiting, let me show this last thing, and then Chris, this is all yours. Is one of the other things that you can do quickly for QA/QC is there are color by face property and color by room property here that can be really useful. So I can do color by, let's say, color by space type, program type quickly. And you see, because I turned off the filter, it doesn't show it on all faces. So I'm going to change the filter. And a couple of things that you can do now, I can see all the spaces. Now we have a legend here that you can edit. Actually, I can move it around. I can click on it and call it program type. I can change the number of segments if I want. I can change the color set if I want. I can do a preview and see how it works. And yes, you can go through all these different properties that we have here, see them, visualize them. Radiance modifier set is not set, for example, in this model, so you can quickly see that without the need to go and like check every single room, and make sure your model is correct before simulating it. Is this QA/QC available in Pollination plugin in Grasshopper? No, like this QA and QC features are only for the Rhino plugin. We have similar features in Ladybug Tools Grasshopper plugin, but they're not as easy to use because of the nature of Grasshopper versus Rhino. Oh, and I repeat the question. The question was, is this QA/QC capabilities available in Pollination plugin in Grasshopper? I already answered it.
All right. So any other questions before I kind of launch into maybe some of the workflows using this clean model back in Grasshopper? Okay. All right, looks like we're good then. All right, so and feel free to like post any questions in the chat, or we'll have some moments where we'll pause and you can ask some questions. So, I mean, you guys see like the process. Mustafa went through that cleanup process in a matter of like 10 minutes, whereas if you were doing this in Grasshopper, it would be well over at least a couple of hours. It would have taken me at least to figure out all these things, and I'd be pulling my hair out by the end of it. So all right, but the thing is that now we have this like really nice clean model, right? And the one thing that we didn't really cover is the fact that we actually assigned all these properties for the constructions. We assigned some constructions that are good for the climate zone. We assigned programs. You know, this is basically being a small office. We assign like restrooms and open office and storage, all different sorts of programs for these, and we assigned HVAC systems to these. So all of the energy properties that you can assign within the Grasshopper plugin, you can assign those to your pollination model here. And now the really good thing about this, though, is that you may say like, okay, this is great. I can build my full energy model in the Pollination Grasshopper Rhino plugin. But you know what? I would really like to still, you know, I like doing my analysis and my post-processing in a visual scripting interface like Grasshopper because it's really powerful. There's a lot of, you know, customization that I can do in Grasshopper. Wouldn't it be great if maybe I can just take my Rhino model and actually just run the simulation in the post-processing in Grasshopper? And that's exactly what we've tried to enable here. So you'll see that I have a little script that I put together here that is simply meant to take a model and run that through an energy simulation and give us the end use intensity. And under the pollination, when you install the Pollination Rhino plugin, you'll notice that you get this extra sort of section of parameter components here. And these allow you to bring geometry objects or some of the other resource objects like constructions and schedules from the Rhino model into Grasshopper. So if I grab this one that's simply called PO model right here, this component will actually allow me to bring my pollination model with all of its properties into Grasshopper here. All I have to do is right click on it and say get model, and it's going to load basically that model from Rhino here. And you'll see this is the same type of model object that Ladybug Tools users would get if they were building the model using this component, right? Using the honeybee model component, right? It's the same type of object. It's just that now it's coming from Rhino with all of those properties, all those, you know, clean geometries and everything. All those are basically contained within this model object here. So I can simply go and take this model and plug this into the run OSM component or model to OSM component. I can set this to true and now actually run an energy use simulation with this model to get, in this case, I'm going to get out the energy, the EUI results, and I'm also going to parse in some of the, you know, hourly data for cooling and heating and lighting so that I can really kind of understand what is going on in the simulation here. Now, this is like only a 15-room model, so it'll take like a minute to run. But you can see, right, like this essentially allows you all of your workflows of actually running the simulations. You can still do those just as easy within Rhino Grasshopper. All of your visualization workflows, like if let's say you want to color rooms with results and create animations of, you know, of the results over the course of a day, for example, right? You can do all of that really customized data analysis and visualization in Grasshopper, but it's just that you're pulling the model from Rhino, right? So Rhino ends up doing the thing that it's really good at, right? It's really good at allowing us to edit the geometry, fix these geometry problems, and identify them. Grasshopper is doing the thing that it's really good at. It's you know, doing post-processing and data analysis and all those types of custom things that we want to do, you know, that aren't necessarily easy to do in a kind of windowed UI, right? They're much easier to do in a scripting interface. So, all right, so in this case, the simulation finished running, and you can see that, you know, you can actually check. I ran this with a kind of baseline packaged VAD system, which some of you, if you know the building code, I know we had a few engineers here, know that this is, you know, that's about the baseline, the code baseline system that you'd run for a small office like this. And you can see we get an EUI of about 300 kilowatt hours per square meter, which is about 95 kBTU per square foot, right? We get that breakdown, and I still, you know, unlike maybe let's say another interface where I wouldn't necessarily be as easily able to look at the hourly heating plots here, the hourly cooling plots for each of those cooling coils, right? I can do this all within Grasshopper just as I would normally with, you know, if I had built the whole thing in Grasshopper here. So, all right, so this is great, right? We still have our old workflows here. But now let's say, you know, now that I can actually make a Grasshopper definition that is dedicated towards a specific task rather than trying to make a definition that builds my whole model and runs, you know, whatever I want to do with that model. Wouldn't it be nice, let's say, you know, I typically want to run the same, you know, ECM, the same energy conservation measure, like the same, you know, for all the models I get, I basically want to try out this one energy conservation measure that I know works well. I can make a dedicated Grasshopper definition for that. So in this case, I have actually a slightly modified version of the definition I just showed you, but in this case, I'm assigning a much more efficient HVAC system. It's a DOAS with a fan coil unit system with a heat pump. I've got some nice heat recovery in here, right? And I can make a dedicated script just for taking any model from Rhino, basically, right? I can get any model from a Rhino file and simply apply this energy conservation strategy to it. But now let's say, actually, let's go one step further even and say, you know, I would like to apply an availability schedule to the DOAS, to this dedicated outdoor air system, so that it can actually, you know, I'm going to shut down the fan basically whenever the building is unoccupied. Well, I could do that using, you know, our old Ladybug Tools components to make a whole weekly schedule. If you guys have ever tried to build schedules with this, you got to use gene pools, and it usually ends up being a lot of work. Wouldn't it be really nice if we can just have a nice UI for making schedules? And that's actually what you are getting when you have these components here. So if I pull this PO schedule component here, this is another parameter component, but it will actually allow me to pull schedules from the Rhino model. So I can simply say, right-click on it and say Set Schedule, and it's going to bring up a little UI with all of the schedules that are currently in the model here. So I have some generic office stuff, some other building office schedules. But, you know, actually, let's say I want to make a brand new schedule from scratch. I can simply say Add a Schedule here. And because this is going to be an on-off schedule, I'm just going to select this on-off type limit. And I get this really nice UI here, right? I can simply say I want the DOAS to come on at 8 and go off at 8 p.m., right? And I can build a schedule in this nice UI, much better than trying to manage lists of values as you would have to do in if we were building this all in Grasshopper. So I can just call this DOAS availability schedule. I can say, okay. I just have to make sure I select this, and you'll see that now, instead of having to use those sort of clunky Grasshopper components, right, I actually get a schedule object that I can then go and apply to this DOAS availability right here, right? So this is the same exact type of schedule object that you get out of those components there. Makes it a lot easier to build these schedules and manage them. And just so you're, you know, in case you're wondering, the schedule will be here the next time you open up the Grasshopper definition. It's embedded within this parameter component. So you can really easily, you know, build up a Grasshopper definition with all your schedules if you want, using that, and then be able to edit them this way. So I could also run the whole simulation like this and get a new EUI, but I don't want to freeze up my computer again. So I'm actually going to run this simulation on the cloud. So I'm just going to, let's say, log into Pollination first here. And I'm logging in on the other screen so you guys don't see my login info. All right, but it'll say, hi, Chris W. Mackey, or hi, whatever your username is when you log into this. And I'm going to get a recipe. Let's see. I'm going to actually, yeah, I'm going to run this under a special project. Let's see. I'm going to do an advanced search for just the one that I own. And I'll just do that by using my little pollination handle here. So I made a special project just for this user meetup. So I'm going to run everything under there, and I'm going to use this, let's see, this annual energy use recipe. This one looks good. I'm going to just select this, and this I can plug in my model here, right, as an input. I can plug in my EPW file, right? This is a very similar type of analysis of what I'm running in Grasshopper here with this model to OSM component. You know, maybe I have another, you know, Energy Plus output here that I want to actually visualize in the reports I get out of this. I can plug this into the visualization variables here for this recipe. And I can just go and hit this pollinate button. Let me give it a name. We'll say DOAS ECM. That's probably not the best name. You could probably come up with better name for your jobs. But I'll just hit pollinate right now so you guys can see this. And, you know, and this run will start happening on pollination right now. I can check the job here. You'll see it's already started running. And I can say check job on pollination. And, you know, and this is then, oops, let me bring this over here, right? This energy simulation is now running on the cloud. So I'm not blocked here. Let's let this run. Maybe we'll come back to it in a little bit. All right, so this is great, right? I can, you know, make Grasshopper definitions for dedicated tasks. But let's say, all right, I know I want to test out this ECM that I use on all my projects. Next, let's say I want to ask the question of, all right, if this, you know, this EUI is pretty high for an office, what strategy should I focus on next in order to be able to really lower the UI even further? And so to answer this question, I'm going to turn to our old friend, energy balances. I'm sure if you guys have used Ladybug Tools a lot, you've made energy balances or load balances in the past. And I actually have a dedicated Grasshopper definition here that's just called evaluate annual load. And in this case, right, you'll see that it just can take a list of rooms. It's going to make some monthly charts of these annual loads for us. But the really nice thing is here, so I could bring in the whole model and plug all those rooms into here, kind of like what I just did before. But you'll notice under the parameters, we actually have a component that's just meant to bring in individual rooms, which is particularly helpful for these workflows. And I'm going to show you this in a second. So let me just grab this PO room component. And I can, just like I did with the model, I can right click on it and say set one room. And let's say I can pick this, this particularly glassy room that I have on the side here. That's part of an open office program, I think. And I'll connect this to this annual loads component. And you guys know this component is very quick. It's made to run simulations, pretty rapidly. It runs a very optimized type of Energy Plus simulation. You see it ran. I'm getting those monthly charts there. And if I go over to top view, you guys can actually see we're getting out a load balance of just this room from our model here, of just our pollination model. And we can see, wow, like what is really driving the cooling energy of this room in particular is this really high solar load. Maybe we shouldn't be so surprised when, when we have like I guess this is a west-facing, really glassy room, right? That's, it's going to have a high amount of solar gain and a lot of window conduction too that's responsible for this high heating energy use. And I can actually, I can see that not all rooms are the same. So I can set another room, like for example, this room in the bottom. It'll recompute. We'll see the load balance is a little bit different for that room. I can, maybe I can take a look at this corridor back here, right? I can set one room there. We see the load balance of a corridor is very different than the load balance for the the office spaces, right? In this case, it's driven much more by infiltration. And I'm sure some of these core zones have even different, balances themselves. Maybe I'll just try one of those quickly, right? You can see every room is different, right? You can actually get a really deep understanding of what's going on in the model using a script like this, using both Rhino and Grasshopper together. And there's certainly also nothing that stops you from just taking all rooms together. So I can right-click on this and say set multiple rooms. And I can just select the whole rooms in the model if I want to make a load balance of all those rooms together. Hit enter, and I think this is only going to take about 10 seconds because it's such an optimized energy calculation here. But right, so you can actually, build tools that are really customized to just looking at individual rooms versus the whole model, right? You get a lot of freedom this way. And you still see that the solar load is a really large term driving the cooling load here, as is the conduction and the infiltration for our heating. So, all right, so let's just say, you may say this is great, all right, I can build custom scripts or dedicated tasks. But this is a static model in Rhino here. What if I want to do a parametric analysis on this model? And you still have all of the capability to do this, right? These rooms that are coming through here, these are honeybee rooms, the same objects that you get with the Ladybug Tools components. So let's say I actually just want to I'm going to turn this off for a second. And let's say I just want to look at, let's say if I reduce the glazing ratio of this room. So I'm going to say, right click on this, set one room to bring this one room in here, this particularly glassy room. And I can, if I go full Grasshopper here, I can just grab one of these honeybee components like the apertures by ratio. I can connect up my room to this component. I can connect up a slider, let's say going from a glazing ratio of 0.1 all the way up to 0.9, right? We get a little nice Grasshopper slider there. I can connect that up to the ratio here, and that's actually going to result in, why don't I can even preview this here. So if I can connect this up here, and let me turn actually the Pollination Rhino preview off. Right, you can see I can just as easily, all those nice parametric features, right? I can dynamically adjust the glazing ratio of this room, and very nicely, right? Let's say maybe I'll put it at 90%, like really highly glazed, and I can connect up this edited room to that same annual loads component. And now I'm going to be looking at a load balance of just this really glassy room, and oh my gosh, it's a huge solar term, man. And this is with code compliant windows. So we can see, right, if we actually were to reduce this glazing ratio, if I were to change the slider in real time, I could actually see the glazing ratio reducing. And you can see, right, if it goes all the way down to 1, I think the annual loads at first were, they were up by 300. I think it was 350 something, right? We can see the load intensity, or the sum of the heating, cooling, and lighting equipment, drops dramatically. Maybe just to drive the point, so it's 230 right now. If this were to be like 90%, right, it's going to jump up to 340. So clearly, there's a lot of energy to be saved by making a case for reducing this glazing ratio like this. So all right, so this is great. I can do parametric analysis like this. I can even show people in real time this is what would happen to your load balance with things like this. And let's say, I really want to build a case for, making a 30% glazing ratio, right? This seems like it would probably be enough to still get decent views of the outdoors, looking at the model right here. But let's say, I'm talking to Mustafa. Mustafa's saying, well, can you still get good daylight if you have that amount of windows, or you still have sufficient daylight? And so in order to analyze this, I have a dedicated script just for doing daylight analysis. So yeah, you can have a script for anything you want to do. And so in this case, I've actually selected all of the rooms in the model here. And you can see I can adjust the glazing ratio of everything all together. So this is, I can do a 90%, oh my gosh, glass box, or I can go down to 30% like that. I'm assigning some grids, some sensor grids, so we can actually look at the daylight in the space. And if you wanted to take a look at those, you can see what those are like in Grasshopper, make sure the grid size is good. But let me go and just push this to pollination right now. I have one of those pollination recipe components up here. I'm just going to call the name of this project Daylight 30, and let's pollinate, send this off to pollination. And then within a few seconds, we should see this running on the cloud. And you may need to Control-E and Control-E again this, because it's just when it first starts up, it might say, the run hasn't started yet. But here, now we can go and check this job on Pollination Cloud. And you can see the actual progress that's happening here, right, on this daylight simulation. So, all right, so we have, you guys got to kind of get a sense of the workflow, right, and we can actually even see that this energy simulation that I ran succeeded. You can see we actually have a lot of nice extra outputs when we do an annual energy use simulation on pollination like this using this particular recipe. So we have, like a little JSON that'll tell us like exactly what that EUI breakdown is, right? In this case, it's telling us, well, maybe I won't show you the EUI yet because there's another way we can look at this. We have a really nice HTML report, basically, that gets produced when we do this. And if I download this results folder and open it up here, right, we get this really nice report. If you guys remember, the EUI was around 300 kilowatt hours per square meter. If we were to use that nice DOAS system with that availability schedule, right, this is going to drop by more than half, in this case down to 140. And you get this really nice report. It shows you the breakdown of heating, equipment, fans, right? We're actually able to see what is driving the energy use. We get monthly breakdowns. There's a lot of nice things that you get in this HTML report. And the really beautiful thing about this is that, right, this is something that I can send to someone else. All they need is the link to this project. As long as they have access to this project, they can see the results of the simulation that I ran. I can even probably show you this visual report here, right, which is another kind of 3D visualization of the model in the browser. And we can actually take a look at, there was that data that I requested, that zone mean radiant temperature. We can actually color the rooms with that data, and even scroll through hour day by day and hour by hour to see what the radiant temperatures were at that time. So, all right, so this kind of gives you a sense of this. I mean, the simulation I think is going to take probably like 5 minutes to run here. So I do have one that is already completed, ready to go, because I kind of want to show you guys one last thing before we kind of wrap up the demo today. And that is that, if I have these results, I've run them on the cloud, I can very easily load them back into the Rhino plugin. I can certainly load them in Grasshopper, and all of my workflows for Grasshopper are still, workable with the pollination workflows here. But when you have the Rhino plugin, the Pollination Rhino plugin like this, we have this really nice load results feature. And so if I click on this button down here, you'll see that I can add results from a different location. I can add both local results as well as cloud results. And so this would allow me, I can, let's say, search for my project that is called, let's see, I think, so let me do an advanced search with me as the owner again, because that really narrowed it down. But of course, if my office had a different project that I was using, right, I can use that one. So I have my user Meetup project here. This will load all the results that I have here. Here's that Daylight 31 that's still simulating right now. And this one already has the results. So if I just simply hit OK on this, it'll load up these results here for this run that I did. I can select what asset I want to load. So in this case, I'll just load the Universal Daylight Integral results into Rhino here. And if I just simply hit load, and give it a second, you'll see that we will get a very nice visualization in the Rhino model here.
Right. So just one comment. That's useful daylight illuminance. I know Chris is trying to wrap it up.
Yeah, I'm sorry,
UDI.
I'm going kind of fast. Yes, this is
Right.
UDI, right? So this is, it's going to show you the sweet
Useful.
spot between not too much and not too little light.
Right.
And you see these results are percentages. As Mustafa was showing, you can customize the legend. So I can add a title that says UDI, so everyone knows that it's Universal Daylight Integral. I can change the maximum to be 100 because normally, percents go from 0 to 100.
Yeah, that's the
I
thing.
can change.
It's not Universal Daylight Integral.
Oh, it's Universal
It's
Daylight
useful,
Illuminance. Oh,
it's
I'm
useful
sorry.
daylight illuminance.
Yes, okay. Useful
It's
daylight.
illuminance.
Illuminance. I'm sorry.
Yes,
Yeah.
for people watching it later. No, it's fine.
Oh
A
my
number
gosh.
of
Yeah.
segments you put to one.
Yeah. Where did I get that from? Okay. Useful daylight integral. Oh, illuminance.
Illuminance. Yeah, you're good. I think you're
okay.
The number of segments should be 11.
Oh, that's why Mustafa's. Oh yes. Oh, I changed the number of segments to 1, so that's why it's like that. So let me change that to 11. Okay. Yeah, and that's proving a lot more nicely. I can change even some of the settings. If I don't like the number of decimal places, I can get rid of those decimals and preview that, right? You can see you can customize everything, and especially the colors. I'm sure, I mean, people love changing the colors. So I can change this to like a multicolored ladybug, you know, I can change it to, there's one that I like a lot here. And what's it? It's just called annual, for these, particularly for these annual metrics. I think, yeah, annual comfort. Here we go. Let me preview this. Yeah, this one I like a lot because it tends to show me, you know, right, I can see very clearly in black the areas that could be better. And a lot of them are actually probably close to the, you know, the windows that were generated in this 30% glazing ratio scenario. And the really nice thing about having this in the Rhino plugin here, right, this is an actual layer in Rhino. I can turn it on and off. I can bake multiple results into here. I can load multiple results and manage them. And especially, right, if I just go and save this as, you know, result, you know, right, the next time that I go and I open up this 3DM file, it'll have the results there for me, right? I don't have to try and embed them within a Grasshopper definition and worry about managing all that, right? This is all nice to do in there. And yes, you can hide the grid line. I mean, that's a Rhino setting. If you just go to options, you can always turn off in any of the views. You can always turn off the where is it? There's a mesh edges. Which one of these? Mesh wires. There we go, right? You can turn them off if you don't like them, right? I mean, so all the visualization customization of Rhino, that's all supported in this. Maybe, yeah, maybe you like this a little bit better. So, all right, so great. So you can save the results in Rhino, right? There's less management there. Everything is contained in the Rhino file, including all of your, you know, the setup of your model as well as the results. But of course, we can say like, all right, what if I want to share these daylight results with someone else? And maybe let's see if actually, if the simulation, this is still running, okay. Or actually, it could be, at this point, it may actually, no, it finished. So sorry, I just need to refresh my browser there. So you can see that daylight simulation that I sent a few minutes ago is done. It finished. And, you know, in addition to having all these results here for UDI, daylight autonomy, which I know is useful daylight illuminance, right? So I could also look, though, at this visualization output that we have whenever we run this, this model on pollination. And you see this visualization output is specifically a file called the vtk.js file. This type of file can actually be previewed in the browser. And so I can load up my model here along with the results. So this is actually showing me the exact geometry that was simulated as well as the results, in this case, daylight autonomy by default. And you can see I can turn off the roof ceiling geometry so I can get a better sense of this. Maybe I want to change these walls. Instead of having a surface preview, they should be a wireframe preview. It's already looking a little bit better. I can customize this data a little bit, right? I can change this, you know, the color schemes if I wanted to use, like, let's say Ecotech instead of the annual comfort, although annual comfort is pretty nice. You can see I still have that useful daylight illuminance, right, value here, right? You can preview this within the browser, share this with people. And even recently, we just added this section box capability where you can go and even drag a section box along this. If you have, you know, this is very useful. You can imagine when you have a 500 room model that you're running a simulation for, right? You can go and just make a section box so you can show all the useful daylight for a given floor at a specific time. Right, so a lot of nice features built into this viewer, and the great thing is, yeah, you just have to share the link to the project with your collaborators, and they can look at this. They have the view to this, and Mustafa actually just shared the link with you to this project, so you guys can all check it out. So I think that kind of wraps up. We kind of covered pretty much everything I wanted to do in this demo. Maybe I'll just do like one kind of summary presentation, unless there are any particular questions.
Yeah. Do we have any questions?
We don't have any questions in the chat, but does anyone have any questions?
We have 5 minutes. So one thing to answer, we can bring up the wrap-up presentation, is you can download the Rhino plugin from our Pollination website. It's Pollination Cloud/Rhino plugin if you go under product. It comes with 14-day trial period, so you can try it for free and make sure it does what you need to do. If you have any questions, you can always reach out to us by email or on Discord. And with that, I think if there is no other questions, we can do the other presentation slide. I don't know. Was it like everything was amazing, so you have no questions, or is just like, what was this? We have no question.
Or maybe you need to try it out for yourself and
right,
see.
then you'll
you
have
guys
no
know, yeah, if you have any questions
Definitely.
that come up
Thank
as you're using it, please post them on our discourse, or search our discourse probably first, because chances are, let's see, if you want discourse, actually you can get to the forum from here, correct? Yeah,
Right,
here we go.
under resources.
Right, just post your questions here or search for them here because we can point you to, like, as you can see, any model, pretty much any geometry issues, like you're able to clean up really quickly with the Rhino plugin. At
Yeah.
least
Chris,
I'd say, yeah.
do you want me to do, like, if you stop, I can just share my screen and go through, and we have 4 minutes still.
Go for it. Yeah.
Just those. And I said initially we might go over, but it looks like we can finish it on time.
Yeah.
Great job, by the way. Thank you for the presentation. So yes, basically the things that will help, the Rhino plugin will help you with. On the model side, we start with this is what we're used to when we work with Ladybug Tools, right? You have model setup, which is biggest part of the thing, and then you have the QAC part, and this is really the simulation part. And one of the issues that we have with this is every Grasshopper script becomes project specific. And in Rhino, you can quickly just move all those modeling to the Rhino side. You can do QA/QC. You can check all the model in the level of every face, as we showed today. And then that will translate your whole Grasshopper script to this. So what really happens is before and after. Not only it's cleaner, it's faster. The other thing is it helps you with reusing your Grasshopper scripts. I think we have a slide somewhere for that too. You can basically like put them in different type. As Chris showed, he had like one small script for daylighting, one small script for energy, another one for comfort. The other big thing is validation, right? You can identify the problems before they become a problem. So I didn't have to run the energy simulation to know those faces are not matching. I could just run PO, check geometry, and that shows me the problem. The other thing is now with the documentation of validation, every problem, I know what is that. I can see it in the model, so I don't have to go find that name, search it to try, like takes me like 10 minutes to figure out which window has the problem. You can quickly see it, it's automated. And in the near future, we will have automated fixes for like the ones that are very common, like this one that does the automated fix for you when the faces are closed. This is a project by Assis that he's using the Rhino plugin for QA/QC. Quickly, you can see the type, color, everything. This is another one showing all the R values for all the faces that you have. Then you can do simulate. Oh, and this one, the one that I was looking for. So instead of this approach of having like everything copy pasted in several files because you have to keep it like that, then you get energy use, annual load balance, and daylight in 3 different reusable, easier to maintain a script. And as you saw, if you want, you can also use the recipes and run them on Pollination. And you can easily move between different metrics that you want to move quicker without being locked in with these large files. Finally, on top of that, you can visualize. We showed you how to visualize the results inside Revit. One of the important ones is you can save it and send it as part of the Rhino document. Sorry, I said Revit. Whenever I say Revit, I mean Rhino. In Rhino document. And what's important with that is you don't have to coordinate this Grasshopper script with the Rhino file all the time. Your Rhino file is now a simulatable file. It has all the data for every room. It has the result, everything. That's all that you need to carry, and that will save you a lot of time. Finally, you can scale, as you saw, for larger studies and run them on Pollination, and you can collaborate. There are different ways of collaboration. One is with result sharing on the web. Now you don't have to send your Rhino file. You don't have to send the screenshots. You can send a live 3D model, and you don't have to do anything to make this happen. This is just part of recipe. It just happens as itself. We don't save the state right now. That's something that we will do. So when you send the link, people see it as is. The other thing is, like, this is for energy simulation results. Again, it's available on the web, on the project. You can collaborate. Projects can be private. You can share it with your client. You can share it with your engineer. You can share it with the architect, like whoever you want to collaborate. The other layer of interoperability that we didn't show is import and export from Rhino. We have customers right now who only use Rhino to export, prepare models and export them to IES quickly. And you can bring actually models from IES back to Rhino and fix it. And then finally, you can customize, right? Like one of the things that we always have in Ladybug Tools definition and like the way we think is we're not developing tools, because if you have a hammer, which is great for nail, as soon as you get to a screw, you are deep. Like that's the problem here. And to resolve that, we think about everything as toolkits, how you can put them together. And that's what the Grasshopper plugin used to be and are. So you have different tools that you put next to each other from this toolkit, and you make your own tool, right? The same is happening here, and we see pollination and Rhino as part of this toolkit. So we're just extending in this toolkit to make it more powerful. And this is the place that this small component that comes with pollination makes a huge difference. Yes, as I said, you can go and download it today and start playing with it. This should be the end of the presentation. I see now questions are coming in. So we will stay around and answer questions. I know like we're 1 minute over. If you have to leave, we will upload the recording so you can watch it afterward. Don't worry about that. And sorry for being late a little bit. Okay, should we go through questions, Junkie?
Yeah, so there was a question about an educational pricing that I answered already. I don't know if you want to add anything about educational pricing that we're not offering at this time.
We don't have any, but we are helping students who have reached out and they need. We don't have anything official on our website. If you're a student and you want to use the plugin, reach out and we'll help you with that.
Yep. And then Loic is wondering, I hope I said that correctly, can the scripts from today be shared so that it can be part of the evaluation? Because we did cover a lot, so if the scripts are available.
Is that specifically asking about the Grasshopper definitions? That
I think so.
Yeah, okay. I mean, we already have like a lot of like samples that we regularly update that have these in them. Yeah, I mean,
we can upload it to Pollination project.
Yeah.
You can upload it to files and people can download it from there. So
yeah,
we'll include a follow-up email with a link to the files from today's meetup.
AKA collaboration on cloud. Compliance software to generate EPC certificate. I think this is there a plan for making it compliant software to generate EPC certificates? Chris, are we going to take this one? I don't know what is EPC here.
I don't know what the, could, I guess, Karthik, could you maybe elaborate? Yeah.
So one thing that we didn't talk about is all the recipes that we showed, you can edit and create your own recipes. We also have the apps that we didn't show. So technically, it's like Ladybug Tools, right? If you want to build it, you can build it. If the question is, if we are going to build it, we don't know what this thing is. If you document it on Discourse and we know more specification, if there are enough users, yes, we can build it for everyone on Pollination. But there's nothing to stop you from doing it yourself. So I think the answer is it's possible. Give us more information about energy performance certificate. Are we talking about LEED, for example? Is it one of the certificates?
I mean, yeah, I can say that we have recipes that are almost there for Appendix G modeling,
right,
which is what is needed for LEED and a lot of other, a lot of other
I think
standards.
this might be a UK requirement, but Karthikeya, if you're able to unmute and elaborate on your request, I think that would help clarify.
Or I think actually a better way to do it is just documenting on Discourse.
Yeah.
Oh, true.
Yeah, you write us a post on Discourse, then we can reference it. Yeah.
Okay.
And here, I just dropped the link for that in. And we do have a question coming in from Francesca about embodied carbon and LCA and how that can be incorporated.
So to Ladybug Tools and Pollination. So this came up like every other user meetup. The reason we do not have it is because we are yet to find a database that you can really use globally. What we think should happen, and hopefully will happen, is when we release apps, people can start build more local versions of it, and at some point we can compile it together. Otherwise, we have the whole infrastructure for building an app for calculating embodied carbon or LCA, because we have all the numbers that you need to multiply with that factor. The challenge is finding the right factor is not as easy. I know a lot of tools offering it, but it's hard to trust any. We are working on some integration with another project that we have in urban scale. Yes, that's the thing. Again, like one of those topics that I want to discuss on Discourse, so more people can get involved and we make sure like we do it right. We can't totally do it, but we want to do it right.
Yeah, I mean, what we can do is we can easily make like a little table output of these are the material layers in your model and these are the areas, or the of these materials.
It's the weights. Yeah.
Yeah. So that you can, you know, if you know what those factors are, you can multiply those material layers by that.
Yeah, and
But yeah,
honestly, I think, yeah, Mitchell was last time saying, I forgot who, like they said, like there is a database for Denmark, right? Then they can just integrate that database for Denmark into this because the building based on where they are, then that factor changes, everyone can use it. The challenge is like everyone is using that, I don't even name it, like that database that's just like, who knows if it's for China, US, like everywhere, like everyone is using it everywhere apparently. So that's the thing. We are concerned about the accuracy. It's not like we can't do it. That's the short answer. Okay. I think then we can wrap it up. Thank you everyone for joining. And we hope to see you next month. And meanwhile, see you on the forum. Have a great rest of the day, rest of the week. Take care.